Hello, my name is Muhammad Ashraf bin Abu Qasim. Today, I want to tell you about our project, which is water pump body. Water pump body is used for increasing the pressure of the water flow inside the car, and to balance the pressure, the pump body volute as a one-piece pump body casing also function as the volute. Objective of this project is to be able to manage the project by establish and planning the machining strategies and method use, so we able to understand how to use the CAD/CAM software, how to differentiate and how to make a comparison, and how to be a professional computer CAD/CAM design for the industry field in our country. We are able to verify the tool to be used before machining process and simulate the machining operation of the model by using CATIA software to be able to generate NC code and operation to transfer the machine to make a physical product. This is our organization chart, which is at the top we have the TS Zulkarnain, which is our lecturer, and the group leader is Marisatul Marisa binti Abu Hashim, and on the left side we have Ahmad Munawi Hamdi, which is our design engineer, also Muhammad Hafiz bin Abdurrahim, and our human resource we have Azhad Azib and me, Muhammad Ashraf bin Abu Qasim.
Hello, good morning and Assalamualaikum to our lecturer TS Zulkarnain bin Marjo. I am Masratul Marisa binti Abu Hashim, and for today I would like to present slide 5 until slide 6. Okay, for the project planning, basically I will describe. We have this design idea, the first step. Second is construct sketch, part design, preparation to CAM, machining plan system, assembly design workbench, advanced machining workbench, and then report. Okay, so for the first one, we need to design idea. We propose our idea to TS Zulkarnain bin Marjo, our lecturer. We choose water pump body for our part because it is very suitable. It match all the criteria needed for this project to accomplish. And then the next step for construct sketch, we first sketch and do the part design also. For both, we do like part body, including the base and also the gear, and also we do the stock. And for the preparation to CAM, we make use of we do a machining plane system, and also we prepare the WPC, and then we assemble all of that. And then for assembly design workbench, we need to choose which workbench before the advanced machining workbench can be happening. Okay, so for all of this process, we need to like study first which tool we need to use, and then after that then can we proceed for the advanced machining, which is we use 4 so far, facing, profile contouring several times, and then also pocketing, and also we use drilling. Yeah, for that, like we need to first following this step like spot drilling and everything, so we need to plan on that. This is the project planning, so we need to plan first before we can ensure the flow goes smoothly. That finally then we gonna make full report about everything that we do during the process. For the next slide 6, I'm gonna explain about Gantt chart. Okay, so as you can see here from the Gantt chart, for the yellow column, that one is the like, okay, for the project management, for the Gantt chart, first actually we need to do the drawing and then the NC coding, so that we can proceed into CNC machining. But because of, as you can see at the yellow column, we have movement control order extension and movement control order from the government, so we cannot move into this NC machining. We just do until NC coding. So as you can see here, the pink box is actually the planning, and the blue box is actually the actual. Although we have movement control order, luckily all the flow here goes smoothly. We managed to finish our project in time given by our lecturer. So for the orange column is the task that is given, such as project proposal, project management, 3D modeling, process planning, cutting tool creation, CAM and machining simulation, NC coding, documentation, and video presentation. So we've been given about 16 weeks to finish it, plus minus the movement control order about like 13 weeks or something, or less than that. So we actually managed to make this project happen in time and finish in time, just as shown in Gantt chart. Okay, so that's all. Thank you.
So let's proceed to 3D modeling. So from this slide we can see that there are part and a part with stop. There are multi-view, which consists of orthographic view from top view, side view, and front view. And now let's proceed to stock. So stock is very important to compute and optimize the tool path. So from here we use 63 length for the upper length and 3 millimeter for the bottom length. Now we proceed to WPC. So the function of WPC is to compute the tool path. So from here, the WPC is well coincident with the stock. So when machining, the tool will start from the WPC.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Abdul Rahim. My matric number B0918101244. So we continue for the next slides. I will explain about plan system. There are some important points we need to consider when we doing plan system. So number one is reference. We setting offset is 0 mm. For approach plane, we setting is 15 mm. For repeat line, we choose 30 mm. And home plane, we select 100 mm, and lastly points we set to default, means origins. So it is on the spot to home plane. Alright, after we setting the offset for plane system, we have to save it to the file and rename it as a plane system. Alright, so we moving forward to the next slide. It is assembly. So after we done doing plan system and plan system is ready, we go to the start command and select the assemble section, then go to the insert and select the existing component, click on the product and pop-up will exist. Near there we select the 3D product file that we renamed previously, or that we saved before, and then click open. Next we will enter the plan system, which is the same step. Go to insert and click existing component, then click near product, pop-up will come out also. Choose the plan system we named early, click open. Then these two files are already included. So what we can do, we go to the next step, which is setting on fix and stop seconds. We need to coincidence by choosing the right point. Okay, lastly we need to click the update button to make sure nothing is left. So why we doing this process? Because we need to perform this process to ensure that the plan system and product are in the correct position before we starting machining. Alright, we continue for our machining process. So you can see this is a simulation video for our machining process. I will explain by pointing once to the video simulation to see more and understanding. So for the first process, we did the facing process. We use 50mm tool face mill to cut quickly. So next, the first process for profile contouring, they cut the base part using a 20mm tool end mill. Okay, this process also uses profile contouring to cut the base part on top, and it goes for the roughing process on gear section as well. So it's a little bit longer because the maximum for depth of cut is 0.5. So we waiting. We can wait until it's finished for this roughing process. Alright, so we move to the next process, which is on this gear section we use the profile contouring also, but we choose the my diameter is 5 mm for tool and mill for good finishing. It also take a long time because we the maximum depth of cut also we select 0.5 mm. So why we choose this diameter, because we want to good finishing. So for the pocketing process, it is the part of the fifth process. So we use the same tool that is 5 mm in size. So when we done, we spotted a drilling process to get center in place using 2.5 millimeters drill center tools. So lastly, deep hole drilling process using 10 mm drill tool. For the last two process, jump distance is 5 mm, so that the cutting has a gap during the both process.
Okay, my name is Okay, my name is Ahmad Nawe. I will present about the summary of our project. Okay, in this CAD-CAM project, we choose the water pump for the product. There's a lot of obstacles and problem within the time in doing this project. Two important things in this project is we had to get the machining simulation and the drawing done. However, we gather all the teamwork to put everything on this project. First of all, we had to decide dimension based on the product we choose in this project. The drawing must be equal or less than the actual dimension. The length of the dimension is flexible and referring the standard size of the drawing. Further that, we had to apply the next step, which is the NC code in simulation, so that the product shape well in the software. During the drawing process, we face the difficulty in designing the curve of the gear in the drawing. It is hard to estimate the dimension appear on the gear for a solid product on the drawing. We decide to try every single size dimension to fit in. At the same time, the depth of pocket is one of the problems that we face. We have the standard size of the depth, but to apply on a software is not the same as actual. Furthermore, we have to change the actual depth less than to fit in the middle of the gear. We managed to try over the limit each of the dimension to get the accurate result. In addition to that, the gear part of this product is the most difficult part. We have to decide what type of process to remove the material in the simulation process. The machining process is using the facing process, drilling process. Okay. Furthermore, for the last slide, in this our project, to summarize this CAD-CAM project, we had learned a lot of new things due to the finish this project. CAD-CAM allows the easiest way to develop of product and product management integration, which means make life easier. After all, we finish this project, we understand the purpose of CAD-CAM machining for the manufacturing industry. CAD-CAM also is a very useful software for modeling and even provide a basis for virtual networking. For the machining, it's good to have good experience in machining process. We learn great technical ability in students by exposure of on-hand practice in laboratory, operating CNC machines, and conducting various experiments using latest infrastructure to enhance research approach. We also can apply this skill to the compute design and manufacturing industry field. At the same time, we apply an environment of communication through oral and written presentation of technical reports, derived research reports, so as to interact with academicians, researchers, and industry practitioners. Instead of using milling machine or lathe machine manually, CNC machine is more easier and doesn't require a lot of man work. Finally, most important is we know the concept of use of computers in design and manufacturing. Thank you. That's all for our project presentation.